Welcome to Intralogistics Insiders, brought to you by Sinaos. Explore the latest trends, challenges, and innovations in intralogistics with industry experts. Welcome to another episode of Intralogistics Insiders. We have today Magí Sanchón, COO at Beta Robots. Welcome to the show.
Hello. Nice to be here.
So can you start by telling us a little bit, how do you get into mobile robots?
I did computer science a long time ago. I used to manage a lot of projects for software development. And I started working with Beta Robots some years ago. Originally just doing some bits and bobs because they need some extra help. And about a couple of years ago, I fully joined them, and here we are now, managing some projects with them, mostly on that side, because that's what I used to do.
For those who don't know Beta Robots, can you tell us a little bit about it?
So Beta Robots is a company that has a full stack software and service, and we try to guide companies that want to build their own robot. And I think one of the key things that we have is that we can actually partner with those companies and really help them understanding from almost from zero. So one of the things that we do is basically guiding a company that has an idea for a robot that maybe it's a little bit outside of the market, outside of what you can buy, and we can help you to understand what you need to do. Things like, okay, what do you need? What lidars do you need? What safety do you need? Things like that. So we have a fair bit of companies that come with an idea, and the idea can be very raw or a lot more evolved. That really depends on the company. And but typically they have a good engineering team when it comes to hardware, but not much understanding of maybe robotics, some specifics, or the software implications.
What do you think? You mentioned those ideas. On what kind of fields of applications have you seen more new robots or new concepts of robots?
So, okay, we work mostly on logistics. That's one market that it's very established, and obviously there's a lot of leads towards that. But we have other markets that are more or less known, that are starting, that it's more the agricultural things about, okay, what do you do? Because it's exterior, there's more interesting different applications or different challenges, in logistics or inside the factory. Most of things the floors will be very flat, typically. If there is something that is not flat, you can actually request that it gets flattened, for example. So you have other things. So outside the agricultural thing is, I think that it's actually, we have several projects with that, and but we have other things that we can have things like rides for an amusement park. There are things that start to be thought about that. There's a whole field about what you could put together with AMRs inside an airport, for example. Are there things that are, there are several challenges. Are you going towards the client side or towards the passenger side, or no? You stay in the back, or you do a bit of surveillance of the whole perimeter, for example. You could have a robot that it just goes around and this. And yeah, a lot of different things. That's about it.
Thinking more about logistics, for companies that want to build a robot, that are building a robot, what do you see as the biggest challenges?
I think that depends a lot on the company. If the company has no previous experience in the robotics, so for example, it's a company that manufactures hardware, like big things, and therefore they have a lot of experience on electrical things. They can totally model and fabricate the hardware, but some of the things is actually to realize what it's really needed for for the robotics side of it. So, for example, how many lidars do you put? What is the visibility of those lidars? So, for example, that you don't put something that is close enough that is actually blocking the vision of that tool. We had different things. No, how many safety buttons do you need to put? The norm says something, but where do you place them? Do you have? Do you put an extra couple because the way that you intend to use the robot is always against the wall, and therefore you need a button at the back, for example, or things like that? Or no, you actually can basically put it in a corner because it's more accessible. I think that these kind of things, depending on the level of expertise of the company that is doing it, they might already think about some of those things, and some others that you discover afterwards, and some others that we have the expertise to be able to say, hey, think about this thing or that thing.
What do you think the companies that want to build or are building a mobile robot, what are the standards that they should take into consideration when developing the robot?
You mean software-wise? Software-wise, there is a lot of talk about basically with one software being able to control several robots. Several robots, I mean types of robots, because if it's the exact same one, it's quite has been quite achieved, I think. But when it comes to several types of robots at the same time, etc., the customer wants to actually just have one piece of software that controls everything. So don't know if I answered your question or
just more or less
a tangent.
Are there other standards also in terms of machinery directives that they should take into account that are critical for mobile robots?
So one of the things that we think that, or a lot of people maybe struggle a bit, is to standardize when it comes, standardize to pass the safety. There are certain tests that you need to do. That depends a lot on what robot you're doing, where it's going to work, if the environment is closed, open, etc. There's safety regulations basically and things like that. And for that, I think that a lot of companies have an overall understanding. When it comes to passing it, it is a bit of a challenge because you need to have that. And then if you have a client and you're at the same time building the robot, another challenge is that the client wants the robot to go faster, for example. And well, the ISO says that you cannot go more than X, where X depends on a bunch of parameters, like is it a closed environment, or is it open, or is it accessible to humans? And you might think, oh, it's not accessible to humans, but actually it is, because if a human can jump 1.5 meters barrier, then it is accessible to humans, things like that.
How hard it is to develop and build a mobile robot? What does it take to do it?
So it's not hard in the sum of the parts. So the parts, I think, they are not that complicated individually. But when you have a lot of pieces that you need to take into account, and sometimes maybe they contradict each other, like I want to go like what we were saying, I want to go faster, but at the same time I have this safety that I need to stop in case someone has fainted in front of the robot, for example. So that is quite a challenge.
What are the key elements of mobile robot?
How is that robot gonna see the environment? How much the environment will change over time? Is it constantly changing, yes or no? So the vision on how the robot will be able to locate itself. You can have lidars, for example, but you can also, with those same lidars, see just the walls or see reflectors that you can put, for example. And you can combine these things or not. If you had a robot that needed to be inside or out, you could combine it with a GPS, but that is not very good inside for indoors, logically. But then you have things that are very important that, yeah, sure, it moves and everything, but it needs to be safe. What are the distances that robot needs to stop? Are those dynamic? Typically, yes, but are those dynamic or what? that those robots, hardware-wise, they have a safety system that works on its own, so it is guaranteed to be safe. And then maybe they have some kind of soft safety that typically can slow down a robot before when it sees someone, for example, or things like that.
Traditionally, mobile robots have been guided. Even though we had vision technologies, they had like virtual paths to follow, especially in automotive and these like very high production environments. It has not been seen as something reliable to have a robot that can decide how to go from point A to B, because it's not predictable. But it looks like more and more they're thinking of going that way. Where do you see the situation now? Where do you see the future here?
You're totally right. This was basically guided because you knew exactly where it would go, with magnetic guidance, etc. So you would know where it goes. But that has a double problem, and one is that it's expensive to put together, and it is not very dynamic. You cannot really change it very easily. Yeah. So the next step would be to put a bunch of QR codes on the floor, for example. It takes a while to do, but then that is a little bit more dynamic. But you're already losing a bit of this very strong guidance. I see that now we're going towards a more free approach, less guided in that way. But for the end customer, this must be guided. And how is this guided? So a lot of applications would have, for example, you could define roads. And this is important because you have, at the end customer, people get very quickly used to see the robot passing through a specific point. So even though you don't put guides on the floor or anything, it's very interesting to actually force the robot to go in a certain path. And you can tell me, and what's the difference to the traditional guided? Well, you can do then things like getting a bit out of the path, up to what level. Maybe you can actually manipulate the robot a bit out of the path and then let it go, and it will come back. So you have a lot more flexibility, and I think that everyone will go towards that in the future X years. Don't make me tell you exactly the amount of years, but it definitely going towards that.
Robots are not working alone, so they are working with people, with operators. They are working with forklifts. They are working with even machines. You can have robots in production doing machine tending, for example. How is that collaboration between them being solved right now, and also where do you see it in the future?
I think that is a very interesting point, because some clients see it as this will be autonomous. Okay, so I'm never gonna attend this, but it is it's a system. It's maybe a more complicated machine, but it's a piece of machinery, and you need to teach operators, to teach people to operate with this, to be able to work with them on a day-to-day. And I think that as far as if the tasks get very clear, okay, when you do this will happen, people get very quickly used to these things. There's no big secret, I don't think. It's just that it seems that it's more and more that is very, very autonomous, but it's autonomous to a point. It's still a machine. You still need people to operate it. They might just do different tasks. So they might help this machine, or it just does different things to the current ones.
Have you had any requests from customers, or are you exploring the use on AI?
Yes, we have had some requests, but it's very then difficult to... It's a double edge, I think, because you might have... there's nowadays a tendency to think AI everything. But for example, a safety system, you don't want AI anything. you want to be certain that it's going to operate in a very specific way. So I think that it has its place. It might have its place in routing, for example, where what robot goes where, if you have a system of X amount of robots, or in deciding maybe you can teach it to basically decide when a robot should just wait a couple of seconds, because maybe if a robot waiting 2 seconds makes that the overall system works a lot better. And on those kind of scenarios, maybe higher level, maybe less safety related, on those levels, I see that this is happening and this will happen. I would be very surprised if we don't have any AI in the near future.
A car today can have more than 200 options. Traditionally, you would have maybe 5 options from a car. And so you could have like more standardized production and logistics line. If you introduce 200 new variants, managing the stock of the parts that have to go into the production line, it starts to get way more complicated. It may not be able to achieve it with guided lines, for example.
When you pass to this next level, not the guided ones, maybe you will be able to very quickly establish a new station or a new pickup station or something like this, even while the system is running. So we have systems where you basically, you can basically separate the task, and you can have someone that is programming the system or configuring it, and that person through a front end basically establish a new station. It can establish that in that station a new robot needs to be there when this new button is clicked, and mind that the rest of the system is still working. So whenever that is active, you can activate it, and whenever that new button is clicked, a robot that is available at that point would go there. So that will be extremely dynamic. It's not, it's something that will be basically impossible to do with the guided ones. If you had guided ones, at some point you would need to stop, and on the traditional guided, you actually need to construct the guidance thing on the floor. Basically, you need to mark the floor or put something, so you wouldn't have a stop. In this one, you will not have a stop. You basically could continue working without any interruption. And you can also, let's say that you started this. Okay, I start working with this new thing. Now I'm going to put in maintenance the whole 3 other stations that I have there. You can deactivate them and not use them. So it's extremely dynamic.
When you see a mobile robot, it looks quite easy to understand the pieces. So you have the wheels, you have the sensors, you have how you're going to manage or move that load. But when we think about the software, it's invisible. So what are the building blocks of a modern mobile robot?
When it comes to software for on a modern system, you have the customer expects an end-to-end system. That means that from controlling the robot, meaning turning the wheels basically, or the vision or whatever the robot is doing, cameras, the tool that the robot might have, like a lift or some conveyor thing, for example, some more typical ones, to basically controlling a fleet of robots. Like what do you do? Yeah, one robot, fairly easy. But when you have 6, what happens with that? What happens with priorities? Do you define, for example, you can define areas where just one robot is accepted, or you can, as we were saying before, roads, etc. You can define what roads they are. Are they waiting for each other? Or as some clients maybe ask, I don't know if that has this, they don't need to wait for each other, they can just pass. Well, then you need to make the room to be able to pass, etc.
So when we think about software, what are the building blocks that you need to put a mobile robot to work?
So when it comes to software, you would have certain aspects like that control the navigation, that control the localization of the robot, how the robot moves, etc. There are a lot of combinations. That is on the robot side. Then you would have a communication between robot and probably a fleet controller or a fleet system. Then in the fleet system, you would have a bunch of things, like, for example, how do you control a fleet of robots? Basically, how do you navigate, but not one robot, but a set of robots? What priorities you give? Other things you will have then, right now you would have a fleet of robots that can navigate, but what do they need to do? So you would have something like workflows. Someone has defined what to do and this. And then now you have the workflows. How do you start them? Do you have external buttons, for example? Some of the systems now have very easy ways to interact with an external PLC that is in the plant. And in there, you connect your green button. You put a green button in this. And when you press, then you have a robot going. So that's yet another system. And one more system you might have that I'm thinking right now for a plant would be, well, you would control probably some traffic lights. In a lot of installations that we have interaction with humans. And with humans, I mean humans or walking, but you can also have like forklifts that don't walk, go fairly fast. So you need to somehow interact with them. An easy way would be, I put some traffic lights and then the priority is on the robots. So then you would have a system that controls those traffic lights, for example. And the last one would be, now you have some robots doing things. You have what things need to be done. You trigger them, but those things are for a higher purpose. So you probably have a system that controls your stock. What number of items I have produced in one place, in another one. And how do you connect this to your system? Well, you probably have an API that connects your stock system to a fleet control, etc. So there's a lot of pieces for an end-to-end. And on the top of it, you would have probably some dashboards. I want to know how my system is doing. Because on a day-to-day, maybe it works, maybe not, but they are working. There are not interruptions, but is it going fast enough? Is my production in line? So a bunch.
This podcast is brought to you by Synaos, the all-in-one intralogistics platform, orchestrating material flows with mobile robots, forklifts, and people to overcome cost pressures and skilled worker shortages. Visit Synaos.com to learn more.
In your experience, are companies that want to develop their own mobile robot aware of the complexity of this? And following up on this question, what is the typical roadmap and the times that they should consider from start to having the robot running into their operations?
So if I'm thinking about a company that does not have experience in software and it's a hardware producer, my short answer is no. They are not aware of the complexity. That is quite normal. You don't know how software is a complicated subject, I would say, in the sense that it looks very easy when it's done and working, but to make it work properly, etc., it takes quite a long time. So I think that many companies are not aware of the amount of people and knowledge that you need to produce a software, especially if you are attempting to do an end-to-end, like from controlling the robot towards like fleet, and on top of it you offer as an API to interact with your software, for example. I don't think that is the big unknown, I would say, or this, especially for a purely manufacturer point of view.
And what is the typical roadmap?
So the typical roadmap that I would say we recommend is that if you don't have the knowledge, but you have a good idea on what next robot you want to do, because you have seen a niche thing, first of all, we would really advise to do a prototype. I know that this sounds maybe very logical for some people, but for some others not, because you discover many things that no one has foreseen, and that might not be solvable by software. Like, for example, the placement of something on the robot actually needs to be changed because of there are many reasons. Like your application puts the robot in a kind of tunnel that makes it inaccessible for certain things. So we do recommend that, and that takes months. So it's not, we're not talking about there you go, 3 months and everything is done. No, it does take months. I think that maybe people are not fully aware of how long it takes, even though you might be buying a software that has a lot of parts already, but to integrate it with your robot, the first one will take several months typically.
We're going to see more and more robots on factories, on warehouses. This also involves to be using different brands of robots. We mentioned VDA 5050 as one of the standards that is settling the most in Europe. Is it that difficult to implement, to make your robot compliant with VDA 5050?
Not really. I mean, it depends on if you're basically getting software that already complies with it. That would be very easy. If you're talking as a software producer, what do you need to do, etc. I think that you can go step by step. You can start if you don't have it yet. You can start by implementing some of it, and then getting more and more towards the final thing. I think that if you already have, if you're making your own hardware and what you are looking is into integrate VDA 5050, a lot of, or many of the software solutions that you have, you could integrate it and it would be quite painless for you because it's a standard that we all have in our heads. Many of our software solutions are already implemented, and we all think that we need to basically be able to put a new robot in an existing system or to integrate them, all of them together. So it's something that your software producer will have really in their heads already. So it should not be that painful.
Thinking about the future, we mentioned before AI into mobile robots, but there are like maybe more clear applications where it could be used. For example, if you have a robot in a warehouse and you have someone leaves a box on its way, what would happen in the past is I have something square in front of me. I have to stop or I could go around. But with AI, for example, you could interpret, okay, what box is it? What type of box? Is this a dustbin? Is it a box from production with product? Is it a pallet? So you could interpret that and maybe send a signal to whoever it's necessary. Are LLMs and transformers, do you think, and what applications, where do you see that could be implemented?
What you described, the typical application that we have nowadays, a fleet thing, would not think about that because the typical fleet would be like whether I can pass or not and have a certain range. But it is true that more and more you put elements in the whole plant to have more vision, then yeah, probably you could do things like that to interpret certain things, or even interpret a thing like what you say, like seeing a box and trying to figure out or trying to send a signal. Yeah, fairly easy. But on the long run, I could see that you could basically reinterpret how your whole factory works. Because the robots, you thought that the original plan that you had for robots are to go from this path to this path. Yeah, well, after X months, maybe you see that actually, if I change this or I change that, maybe I can tweak it and improve my layout. So yeah, it could. I think there are usages on, as we were saying before, no, like we said that the AI uses are on a higher level, maybe, and that could be a good way. Like reinterpret, is my installation correct? Like or maybe there's a more efficient way of doing it. That maybe AI can help on that.
Many times, mobile robots are seen as a way to be more efficient, productive, to increase operational efficiency. But in other applications, they are meant to keep humans safe because it may not be a safe environment for humans. So what has been the toughest application that you have been working on for a mobile robot?
So one of the simple cases that we have is in the agriculture. That is not very, very rough for people, but it's something that it can be helped, temperature, etc. But the extreme case would be on something like thousands of degrees on metal foundries or things like that, where you actually have a robot there, like picking up waste and things like that. So even though you might need some human, like as human interaction, you minimize it a lot. So you can help on that front.
We are seeing many brands from Asia introducing mobile robots, not just mobile robots, cars, everything.
Absolutely.
Into the European and American markets. What's one way that we can compete and offer better products, offer better solutions to customers?
So one of the things that I think that competing on price on the same thing, it would not be very smart. That is not. But one of the things that the local or more local companies, we are in Europe, so European companies could do, is actually support. Basically, you give a good support to the end customer. They would consider that because let's not forget that at the end, the system must be working typically 24/7. So you cannot wait for, I don't know what support to take a long time. So local support, helping on a more one-to-one, that could be a really good option for local brands to develop their own and to provide as a service. So going more towards the service and not just the machine, but a package.
But how long will that last? Because those companies can open subsidiaries and have local support as well with local engineers.
Yes, they could, but that's not the case right now. So it's a big market. I think that, as I said, it's very hard. It would be, and it is very hard to compete just in pure economics with the machine. But let's not forget that it's not just the machine that you're selling to a customer. A customer, you have a relation, you have this support, you have how good you are, you have a reputation. Could external brands come and this? Yes, but it's not the case right now. We will be seeing this maybe more, but I think that this is a strong point from the local, in this case, European brands.
The future of mobile robots, especially from Asia, we're seeing very standardized robots coming at very affordable prices with very good quality as well. But is the future of mobile robots like having 3-5 different versions of models, or do you see it as a more atomized market with more specialized robots for each application?
I think that it really depends. I think that there are some, so for example, in logistics, you will have a lot of applications that are very similar. So some of these robots that are very standardized and these, they could work. But at the same time, we do have examples of niche robots that work very well for a specific type of product, and that is a non-standardized robot that maybe a big manufacturer of robots that focuses just on the price would not be interested in even doing. Because why, if I can sell thousands of this very simple one or very standardized one? So yes, there is definitely a bit into niche robots or for niche markets. And let's not forget that afterwards, maybe just next to the niche market and this niche application, you need to do a standardized thing. And at that point, VDA 50/50, and at that point I integrate another type of robot, and at that point it would be when it's interesting how the software and the standardization works. But for starters, yes, you could have a very niche robot because there is a very niche application. So
we are seeing e-commerce warehouses are going fully automated with robots automating from tote to person, pallet to person. We are seeing also inside processes, automating materials to machines. Where do you see the biggest opportunities for automation that have not yet been tapped?
Oh, when it comes to logistics?
Yeah.
Well, logistics is a lot more worked already.
But still there is only like how much percent? 30%, 40% automated?
It's even less. I think it was 20 some.
So there's a huge opportunity there. Why are we not going there?
But is there, I do not know if the opportunity is on different applications, as you were suggesting, or on just that it has not happened on new factories, for example.
And what do you think? What's stopping it?
Well, one of the big stoppers is that you're already doing it one way. That happens in plenty of cases. What should I do? What should I do it this way if my Excel already solves it? That is a typical thing, not in robotics, but as a human to human. No, it's a very normal interaction. The same happens in factories. I already have a system and it already works, and it's an effort to actually install it, etc. Okay, but on the long run, we will all go there. And I think that right now, especially in logistics, but also in other environments, we are seeing that everyone is waking up, or more and more people are waking up and saying, like, in 5-10 years, this will be this way. So I'd rather start trying, install a first robot, a lot of one robot installations to see how it works, and then from there growing to more. So I think that, yeah, maybe we're not yet going there, but we are definitely going there.
What would you say to those that are still afraid to make the move?
Don't be that afraid, because it's very easy to try a bit, actually. You don't need to change your whole system at once. You can do a little bit. You can start with one robot that does a simple task, that it already does a very monotonous task that you don't want to do. Some of the tasks that we have is like bringing pallets from point A to point B through a long corridor. That is hours and hours spent by that the robot can just this, and then you focus on the two ends. So you can change bits. So I don't think you need to be that afraid, because you could just apply a bit of it in your current environment.
So thank you very much. Thank you for joining us, and hope to see you back soon. Thank you.
Thank you. Oh, sorry.
Thanks for listening to Intralogistics Insiders. Stay tuned for more insights and subscribe on Apple Podcasts, Spotify, or your favorite platform.